Buckle up for AEC Trailblazers, the Founders Files, where we crack open the stories of the brightest minds in the AEC startup scene. Forget institutional pitches. We're diving deep into the real personal journeys of these industry disruptors. Get ready for some casual chats firsthand.
Hello, and welcome everybody to another episode of the AEC Trailblazers podcast, where we interview the most amazing minds of the AEC. Today with us, we have Stacy Smithley. She, with more than 20 years of experience, has been supporting sustainability efforts across the build space. Stacy is the executive director of the nonprofit Building Transparency, where she inspires climate actions across the building design and construction industry, facilitating the reduction of embodied carbon through open access to sustainability data and tools. Stacy, welcome to the show.
Thanks for having me.
It's really cool what you do. First of all, can you tell everybody where you're based?
Sure, I'm in Seattle, Washington. Our nonprofit's virtual, so our employees are kind of spread out all over, but the home base is where you see me right now in my kitchen office.
Well, before we started recording, we were like talking about your dogs, and yeah. I think we need to mention your two amazing dogs before we get started with this.
Absolutely. One of them you might see if you see the video on and off in the background is Chuck the pug. He's 5 and he likes to be up on the furniture and keeping watch in the windows. And then under my feet, I have a 8-month-old Great Dane puppy who is already 115 pounds. Her name is Rosie. So she might make an appearance. She'll be almost as tall as me if she stands up.
I hope that happens. That's going to be fun for sure. But you were always been in Seattle, or you studied another place?
Yeah, I grew up in Clackamas. Actually, it's a suburb of Portland, Oregon, so always Pacific Northwest based. And I headed up north to Seattle for college, where I studied architecture at the University of Washington. Go Huskies! And have just stayed here ever since. I love it here.
That's beautiful. There's so much nature in Seattle, like Mount Rainier and the Olympic Park. Sorry, I'm a fan of hiking, so every time I go there, I take an opportunity to do some activities in the nature.
Yeah, I think that's one of the reasons I do what I do is I've just always been in a place where there's trees and water and mountains and everything all around me.
Nice. And you're doing a lot to keep it that way, right?
I'm doing my best. Yeah, I am.
But before we dive into exactly what you guys do, can you tell us how everything started? Like, you decided to start a nonprofit? It was always on your mind. The topic behind your Building Transparency was always in your mind, or how was it?
Yeah, actually, if you had told me I'll kind of tell you how I got into this in general, but if you had told me when I was a little girl that I'd be doing what I'm doing now, I wouldn't have believed you. So I mentioned I grew up in Clackamas, Oregon. It was kind of right on the edge of suburbia down near Portland, where housing developments and kind of strip malls and all those types of things were kind of encroaching on Clackamas. And my grandpa had a big plot of land where he built a house for him and my grandma and my mom and I. And it was on this hill of forest that he had owned. And so I would always just go outside into the forest with like streams running through it and these trees that I would name, special trees for different purposes. And when I was around 8, he was getting up in years, so he decided to sell off the land and keep the house that we lived in. So I watched that entire forested area that had been my playground get basically bulldozed and clear cut and turned into asphalt cul-de-sacs and all these houses that looked exactly the same where my trees had been. So I'd also been doing a report on Julia Morgan. She was the first female architect to be licensed in California. And I got really excited and motivated by her and how she was doing things for the first time and as a woman leading her field. So I told my mom I was going to grow up become an architect and build things that didn't destroy nature when I was 8, and I was watching kind of the opposite of that happen to me. So that's really where it started. But I grew up, I did go to architecture school, as I mentioned. I designed green buildings as I worked to get my architecture license. Never got my license because as I was designing these buildings, I was connected to Skanska, which is a very large construction company, who was building one of the net zero projects that I designed, a living building. And I saw a much bigger impact that I could make if I went and worked on the construction side. So then I became a construction estimator at Skanska, worked my way into a sustainability director job. And it was at that job when Skanska started looking at how to track these emissions and impacts of materials that I really dug into the topic that I now spend all my time on, which is embodied carbon emissions of things like concrete and steel. And I was trying to find the data that I needed to do that work for Skanska. I couldn't find a tool or a database that had what I needed, so I asked them to fund me creating one. So I kind of veered into software development, and I really wanted the tool and database to be free and open so anyone like me could access it. And once we launched it with support of Microsoft and a whole bunch of other industry partners, we founded the nonprofit, and I became an executive director of a nonprofit. So definitely not planned in a very linear way, but I think I've landed where I'm supposed to. And it's really about how to make the most positive impact that I can to mitigate climate change. And I feel like this is such an important topic. This is where I should be spending my calories.
It is. And first of all, thanks for doing this and keeping this open for everybody to use. I think it's an amazing thing. And if you ask me, to be honest, it sounds really hard to me. Like if you ask, I know I'm so used to, running startups and running businesses. So if you tell me, you need to run a nonprofit, I would be like, how am I going to do this? Like, I don't know how to run a business if I'm not making a profit and taking money out of it to pay my bills. How is that different in your experience to a regular business?
Yeah, that's a question I get a lot, actually. VC funders and other startup entrepreneurs ask me this question a lot because they really don't understand how we're doing what we're doing. And it is interesting. I landed in it not in a way of me being strategic around the financial side of it, but really understanding that to make the impact that we needed to, that it needed to be free and open so everyone could just really use it without a barrier to entry. What happened is that by doing it in a nonprofit setting where that's really the mission and of the nonprofit is those who can pay, the large companies that are trying to access this data and use it, the Amazons and Microsofts, they do. So they fund us and they feel good about that because they can leverage our tools. We can customize them for those larger companies while, any of the features that we develop that would be for the public benefit and all the data remains free in the free version. So it's a unique model, but we have partners and funders that are using our tools and data and see the value in it that give us funding. We have grants through folks like Breakthrough Energy, where they are in for-profit investments going to try to help decarbonize cement, concrete, steel, and things like that. So they have companies they are going to make money on if those technologies are adopted. Our free tool helps their technologies get adopted. So they see the value of funding us through a grant to make sure the data around those products can remain free and open. So we kind of landed on this unique, I think we should do a case study or some kind of white paper because I think it's an interesting model. I think there's more types of data and tools across different sectors and across different environmental impacts that could really maybe continue what we started and kind of build on it as a business model.
It is interesting because the harder thing of a nonprofit is, getting funds to actually build something. And like you said, sometimes it's hard to explain this to VCs or dumb entrepreneurs like myself that have never done it. But how do you deal with, you said that big companies pay for it, but if, I don't know, a student wants to use it, will not have to pay for it because he doesn't have funds to use it. How do you filter that? How do you filter that? Like, I don't know, I'm a guy on a big company and I don't want to pay anyway. So you filter every person that subscribes to the platform, or how that process
anyone
works?
Anyone can register for free. And really the value proposition, we haven't done a lot of marketing. People will come to us and say, Can you help us understand how to use this tool? Can we help provide more information around features we'd like you to build into it? And we kind of organically become pilot partners that fund us at a lower tier for a company to have access to early features, which is kind of a typical SaaS model. But at the same time, get support from us and know that whatever they help us build will end up in the free version for everyone over time. So I think to date, people have come to us and they've wanted to support us and they've wanted to help build and continue to basically make the free version of the tool and the database, better and better over time. I think one thing that is interesting as we continue to scale, we've got around over 50,000 users now across the world, over 70 countries. Our database now, in terms of the data that we provide for free within our tool, but also for any other tool to use, as we're trying to kind of align this data across different tools, there are now startups, for-profit startups that are building their whole business model on top of our database. So, we've seen our API calls, calling the data out of the database spike up to 2 to 5 million per month sometimes and back down. I think we had over 10 million calls this year to date. And there is kind of a strategy that we're looking at in terms of how, if you're building for-profit solutions on top of our nonprofit data, the same kind of partnership of funding, it would never be at the same kind of scale of cost that you'd see in a for-profit database. I think there's a give back there that we're starting to have, partners like Tangible, it's a startup that's doing real estate level portfolio accounting on top of our data. COVE tools, energy modeling tool that's pulling our data in. They are supporting us. And I think that's this ecosystem approach of let us solve the data problem. Just continue. If there's a value there, support us in solving that problem. Know that it's going to be for the public benefit. And then profit on top of it, I think is really where we're kind of headed, the sweet spot that we fill.
I love it. It's like you do good deeds and good things happen to you in return. And I love it. And I also love that you have now been doing like a lot of marketing, and because it's something that we all need. It's true. Like it's hard to get like good data regarding embodied carbon. Like there is not many good database around, and it's hard. So it's really interesting. And how at the beginning, how do you start? Like there are so many materials and items, and how the first day, what did you decide? Like let's go with concrete, which is the most pollutant material, and then go with materials that are not as pollutant, or
that's really how we structured the database. Even when I was looking at it for Skanska, if you're trying to do carbon accounting, you're trying to make the biggest impact on decarbonizing stuff. In this case, the construction materials that we build things with. Where are the heavy hitters? And, cement, concrete by itself is upwards of 10% of global emissions. Steel's on the list at a high percentage too, kind of following cement, concrete. There's glass, aluminum. So those heavy hitters first, if we can start and really pilot and urgently try to aggregate the data for those kind of high emitting, high impact material categories, we can then leverage the how and the what that we learn in that work as we work to get it more and more perfect and more globally applicable to other categories. So we started with 9 categories when we launched the tool. All those heavy structural materials, the envelope materials like glass, metal framing, insulation, and then a few major interior materials. If you think of quantity of things like carpet or resilient flooring. And then we've expanded to almost, I think we're over 250 material categories now over the past 5 years, as more and more manufacturers and, purchasers want more and more of these materials covered. So I always say it's like peeling back the layers of an onion. Embodied carbon is like they have to start out in the outer layer, and it's kind of painful and your eyes water because it's so complicated, and you just have to keep pulling the layers back and increasing the scope and really pushing for the data to be as credible and comparable as possible.
Very interesting. And I bet that a lot of your time goes to like putting new materials into the database and analyzing, getting how much, and making the calculations to then put how much carbonates on that specific material. But part of your job, I bet, is also to going back to previous materials and adjusting something that is not 100% accurate. How much time would you say like it takes one compared to the other?
Well, I think, there's different types of data, and really, when I was looking for this data, I was trying to find stuff that I could say was verified and that could be comparable. And I landed on third-party verified environmental product declarations, or EPDs. And that's basically the output of a life cycle assessment for a material that's following ISO standards and a product category rule that dictates how you do these calculations and what you include. And then someone verifies that, like a UL or ASTM or other program operator entities that are verifiers. And then it gets publicly published. And they were living all over the internet. And basically what I did was figure out a way to digitize and aggregate them into a central database. So that whole process is really how you can iteratively get to the best quality data. And what's happening now is the rules around those EPDs are getting even more specific and more rigorous to increase the comparability. So it's a cycle. Provide the data, show transparently how inaccurate it may be based on the current rules, which we do in the tool, and then go back and help advocate for the rules to get better. As the rules get better, I call it the blue squishy stuff because we just show a little blue bar around the number. The technical term is the uncertainty in the data, but the blue squishy stuff can get smaller as the data and the specificity of it gets better based on the rules improving. So we're just kind of that aggregator in the home, and then we can use that to go evangelize and advocate for the data to get better and for more data to exist in that loop.
Interesting. But have you ever considered being a validator yourself, or you don't want to get into that rabbit hole?
No, I think my philosophy, and it's not everyone's philosophy, but I think it's important, is that we can't have one kingdom to rule it all when it comes to this data. One entity that thinks they can prepare the data, verify the data, and house the data, because of the need for that rigor around the trust in the data and the transparency of it. So there are those that can generate the lifecycle assessments following the rules. There are the verifiers that can then, publish and verify the data that's been provided to them for review. And then that data needs to go somewhere that's also an agnostic, again, aggregator. And that's the role that we really aim to fill. If someone tries to do all of that, I think the trust in the verification and the trust that it's for the public good, and that, each one of those steps is followed in a way that's rigorous and not just to benefit that kingdom.
True.
Can start to be in question. So we are definitely an ecosystem player. I think there's enough business where we need experts in every single one of those layers, not someone that's a generalist around everything.
True. That makes sense. And I could see this reflected in many different parts of our industry where there is so much to do, and there are so many, not only materials, but processes, type of buildings and there have been a lot of companies who have tried to do the whole thing, like, from prefab, trying to do design, prefab, installation, to companies doing the whole, design of architectural design, structural design. And it makes sense when there is only one big player doing the whole thing. You can lose quality, or it's hard to maintain the same quality. And
yeah, I just think no matter what, if you use that kind of design and structural engineer contractor lens, there's so much expertise and knowledge that you must have to be a subject matter expert in each one of those things. That approach where you just be really good at this one thing, but make sure that you're part of that ecosystem and the engagement's happening across all of those experts. I think it's a good analogy on the data side too. We just have to make sure, I think we call ourselves connective tissue sometimes at building transparency. We're a small but mighty team, but we're like the connective stuff between a lot of these folks, whether it's designers to contractors and how to use the data, whether it's policymakers to private owners and how to make sure they're saying the same things or requiring the same things, and then all the data providers and verifiers to help them do things in a way that's going to be easy to digitize and verify. So it's interesting. But yeah, I definitely think we're in the ecosystem bucket versus the kind of siloed one to rule all type of scenario.
No, that makes sense. And regarding the use, who are the ones who are using building transparency the most? Are architects?
It's really interesting. When we started, I think because the easiest thing for you to do in the tool was to go into a category and just compare and be able to specify and pick a product during your design, and say that this is the one I want to use and this is how I'm modeling it. So we were about 30 to 40% architects to start, and then about 10% everything else: contractors, structural engineers, civil engineers, manufacturers, sustainability consultants, policymakers, government, and then educational institutions. It's switched. It's kind of changed over time, where I think architects are around 20% now, and the general contractor scope is growing as policies now are saying the general contractor has to be the one to actually track this. It's pretty diverse, but I do think the ones that are really responsible for the design and actual accounting of a project, whether if you think about the cost and the materials, it goes from the architects, engineers to the contractors. That's really our sweet spot, is making sure they have an easy way to do that work for the owners and policymakers. On the flip side, though, we're seeing a lot of use in the data and analytics around the data to help inform policy. I'm very, very proud of our role in the Inflation Reduction Act policy that was put out, the low carbon construction materials piece of it, which is about $6 billion of funding to go leverage EPDs to procure low carbon concrete, steel, asphalt, and glass. And we used our data to help inform what the government would need to do in terms of increasing EPD production and use, and then being able to actually support the purchase of those lower carbon projects. So we're doing a lot with the states now. We worked with the UN on some of the work they're doing through an initiative called the Industrial Deep Decarbonization Initiative. So there's the tool use, I think, on the front end of the folks that have to actually be the ones accounting and designing and specifying. And then on the back end, the use of the data to really inform the policies that then can put out the requirements to them.
Very interesting. I do think that, I think it's related also to the way the contracts work on a construction project, right? That I feel everything is are silos where architects are doing T&M and they just do the design, but then GC, they're doing close budget and they're doing change orders, and I do think that in that case, contracts are going to change in the future, and everybody will share, not only the losses, but the wins. And that way, everybody's going to be, everybody will want to do their best to get a successful project, including the owner, for sure. But I do think that also applies to embodied carbon. I may be mistaken, but I think that every player in the project should be aware of, like, hey, how much embodied carbon the materials I'm using has. So I don't think that should only be architects or GCs. It should even be subs as well. Like, everybody should be aware of, like, hey, you're hiring me to do this, but even if you're a plumber, hey, you're hiring me to do this, but look at the numbers. Like, you cannot make me install this because the X amount, max amount of number of embodied carbon is this.
Yep.
So you think that's going to happen eventually?
Yeah, I mean, that's the analogy I used very early. I was I'm a right brain architecture type person, but I had to do estimating at Skanska when they first hired me because it was before they had a sustainability department that I worked myself into. But that estimating knowledge was really important because the way that we look at costs, dollars of a project is exactly how we can look at carbon emissions of a project. It's a budget, it's a currency. So carbon as a currency was how I framed all this. And just like you have a cost budget that you have to be under, it's very easy to do the same thing on the carbon side. Here's my budget. I want to reduce it by this much. And you can track the carbon emissions just like you do in costs. So the easiest thing in my mind is just to add a carbon column right next to the cost column. Every time you're looking at the cost of something, making a decision during design all the way through construction procurement, you're looking at the carbon and the cost. And that's really what the data is there to help provide, is to fill in that carbon column.
Interesting. And you think, because nowadays, developers mostly ask for, be aware of embodied carbon, embodied analysis and carbon analysis, and based on, not only because they believe it's good, many of them might do it, but most of them do it because of, laws and policies that regulate this. But you think that that's also going to change, and also consumers, companies who are buying apartments or single families or condos, whatever, are going to be also interested on this. Like when you go, to Walmart and you look at the fridge and you see the amount of energy it consumes. It's really easy to see, and you always go for the one that consumes less energy because it's better for the planet, and besides you pay less money on energy bills. Do you think that's gonna change and happen in our industry as well?
I do. I mean, that the thing that's exciting to me as part of the IRA funding is the EPA. One of the things they're doing and they have funding to do is to put out a carbon labeling program leveraging EPDs, where just like you would have the Energy Star label for energy, there would be a complementary embodied carbon label that you would see, starting with the materials that we have right now. But you can imagine going to Home Depot and looking at gypsum board and being able to have, the little stamp without you having to understand all the wonky stuff around the peeling of the onion, like the technical stuff. But just a consumer knowing, okay, my fridge has an Energy Star label. This gypsum board has the whatever they call it, because they're creating it right now, label. So I'm just going to buy that one because they're all here, and that's the one that's the lowest carbon. It's telling me that. And you'd be able to scan it and go back to the data if you wanted to look at it. I mean, I definitely see that. My son, who's now 13, during COVID, he'd hear me working on this stuff and demoing our EC3 tool. So I had him do a project in the tool just to see if he could do it as a 10-year-old, and gave him a list of materials and told him to go pick the lower carbon ones. And he did it. And I was like, now I could say that EC3 is so easy, a 10-year-old can use it, which is great. But he said, Mom, why can't I just go up to this window and scan it and have it tell me the carbon content? Like, you have the data. Why don't you just put codes on everything where you can just walk up with your phone? I'm like, you're brilliant. And I do think that's possible. And if he could jump to that as a 10-year-old, then I think there's hope that we'll get there.
Eventually. I love the analogy of you making your son test the tool. What I always say is, I do it with grandmas. It's like, hey, if your grandma can use it, it's a good tool. If your grandma cannot use it, then it's not a good tool. But I like the 10-year-old better than that. No, absolutely. And then the same, I think it will apply also to like what happens in New York, right? Or California, or many states where if your energy consumption is above a certain threshold or something, you start paying more money. The same is going to happen with embodied carbon. You want to build it? Just do it. But then you're going to pay much more taxes compared to a building that has lower embodied carbon.
I think we're definitely headed there. There's already policies coming out of California that are playing in that space at the material level and the building level.
Yeah.
And again, it is just another currency that you can regulate as long as you have the data to enforce the policies.
Correct. And it's so hard. Like when you were mentioning about these people who validate and calculate the amount of data, that's also so hard. I remember I attended a course on this, and the problem is, how far do you go to calculate the carbon of a material? Like, it's just the fuel and the energy that the factory is using, or it's also the amount of fuel the truck is using to, bring the materials from the source, or it's also, the clothes, the guy it's so hard, but at least we have a baseline nowadays, and I think that's the important thing. And
it's getting easier. I mean, I think again, starting with concrete was necessary because it's high impact, but it's also the most regional of the materials, concrete and asphalt together. If you think about, how far it can travel from the concrete plant or the asphalt plant to where it's being poured, it has to be local. And also one concrete plant can have, 300, 500 different mixes, right? So there's this generation of data that's at a level that's really on demand for the projects. And now we have EPD generator tools by more than one provider that a concrete guy can have put in at, or girl can have put in at their plants. And they actually source and verify all those things you talked about. So where do you get your aggregate from? Where do you get your cement from? How far is it traveling? How much do you get? And it's a calculator that they put in. I got this much cement from this supplier and this aggregate from there. And they can customize that. It'll spit out the EPD information. It will go to a verifier. They will digitally verify it, and then it digitally flows into our platform. So we've grown from 1,000 concrete EPDs to over 80,000 mix-specific concrete EPDs in 5 years.
Huge.
And the cost went from somewhere around $25,000 for a concrete supplier down to $1,000 to $5,000. So if we can prove it for concretes, that means it's possible for everything. And now it's just that scaling effect. And fortunately, those EPD generator providers can be for profit and can actually make a business out of this and compete against each other to provide this information at scale. So that's one of my success stories I like to share, just because I think it is hard, but if we can figure it out for one material, it definitely is translatable to more.
Absolutely. And it's really, it's great. Like you can have that trustability, and you can actually compare providers that might even have the same price. Like, hey, I don't care about embodied carbon, but if you have the same price, like, let's say I don't care. I care, but let's say both have the same price. Both providers have the same price. You would always go with the one with less embodied carbon. Why not? So even if at the same price, it's so great. And it's something that I always say, like, we care so much about food, right? Like traceability of food, and because it can be poisonous or whatever, but we don't care so much of the materials where we're building a place where we live most of our lives. So it's just insane how traceability is getting so much better, not only on concrete, but many types of materials in our industry. But I do feel that there's still a long way to go in terms of traceability and the different providers or suppliers that are feeding, concrete factories or brick factories.
It's the next layer of the onion. It's the next one we have to peel back. We're getting there. But yeah, we're not there yet.
Really? But you think that in the future you're either going to be able to, I don't know, double click on a concrete provider and then know where the cement comes from and where
we already are. I mean, there's already
Nice.
there's cement EPDs that are happening now. So if you think about the layering of all the supply chain stuff, aggregate EPDs, so all of a sudden that concrete EPD for the end mix has a verified source for the cement with an emissions factor and a verified source for the aggregates, and then that gets assimilated into the concrete EPD. We have examples of that where we can say that an EPD is 80-90% supply chain specific because they've tagged the cement plant and the EPD that was used as the input. So I think it's how we push EPDs up the supply chain, because then the verification also gets pushed and the digital push of the data also happens. So we're starting to see it. I think some materials are going to be harder than others to do that. But if we can get cement and concrete sorted, we're one full step ahead when it comes to the impact on emissions reductions.
No, absolutely. And you're pushing these providers forward in terms of, like, if they see their sales going down a little bit, or they see that their competitors are selling more because the data is there that they're more environmentally friendly, they will have to do it.
Correct.
Like, even if they don't care for it, they will have to do it. Otherwise, they will be out of business. So it's really interesting how powerful data is in this case.
Yeah, 100%. Yeah, I think it's a little different than some of the other kind of sustainability categories, where it gets a little more challenging to push the business case. But this one, absolutely, because of how the data can be right there to make it a procurement decision. And it is kind of like a currency that goes up and down. And then, the concrete guys, my other favorite thing is when I first started, I went to the local concrete suppliers here in Seattle before I knew a lot of what I know. And I said, if I ask you to provide this EPD thing, and I tell you that, our client or Skanska is going to judge you on not only your costs, but your carbon emissions of that mix, what do you think? And they said, well, no one's asked us to do that, but I know today that I can go optimize this mix and give you a lower carbon one that's cost competitive. We just haven't been asked to. So that ask and the ability for them to then show and know that they have to optimize cost and carbon, it led to about over 5 years, we've reduced the emissions of concrete from the major suppliers in the Seattle area by almost 20% generally, because this market now
Huge.
leverages this and requires this kind of competition to happen based on the data being there. So
Interesting. And most of these suppliers, you approach them? Like, I bet at the beginning you did because you were new in the market. But nowadays, most of them approach to you? You approach them, or it's kind of a mix?
it's a mix. We have good relationships, and we've had partnerships in the past. Even when we were incubating the tool with the National Ready Mix Association for Concrete and National Ready Mix Concrete Association, get that right, and the AISC, the Steel Institutes. So we involve them in the process at the industry level. But now, it could be that an owner is requiring an EPD in the use of our tool in their specs and contracts. And it goes all the way down to the manufacturer. So the manufacturer is reaching out to us to make sure their data is in the tool. So, it's really, it's coming from everywhere right now. But, starting to see people say, well, is your data in EC3, is a really good kind of proof point for us, of the value of having a place where it can live.
Interesting. And how do you deal with like international manufacturers? Like US, it's easier. You're based in the US, but when you have to, I don't know, get manufacturers from other places, it's as easy as doing it from the US, or?
No, there's definitely the two markets where actually there's the great thing about EPDs and this whole life cycle assessment is that it's globally applicable and the standards are global. So we actually have thousands of EPDs from the European market, Australia. We're seeing those start to pop up. There's an EPD Egypt. There's an EPD China, because it's just a common way of actually publishing this data. So that makes me really excited. We have, data globally now, and then we're filling in the gaps as we can. There does need to be alignment around those product category rules. Like the way that concrete's being done here in the States is not exactly the same as in the European market. For material like concrete, it might be okay because it's local. But if you get into something like steel that could be coming from China, right now they might have to have two different EPDs following two different sets of rules. So depending on the market you're in. So we're doing, again, that UN level work is how you harmonize the rules that people are publishing to globally so that the data is globally comparable. That's yet another layer of things.
Yeah.
But,
another layer of complexity.
Yeah, the bottom line, though, is that EPDs and life cycle assessments are a globally applicable and accepted method, which is good.
It's cool. And do you feel the US is leading on this, or is it Europe, or?
I think Europe and the US are definitely kind of in tandem. And now the good thing is we're talking to each other. The European side, I think, started kind of at the higher benchmark level. Now they've gotten to the point where there's EPDs, there's material passports, there's product carbon footprints that are kind of all happening over in Europe at the same time. I think because it wasn't as far along here in the US when this, a handful of years ago, everyone here, I think, really aligned around environmental product declarations as the source of the data. So I think we're moving a little faster maybe in the US using this one type of data to start to inform these policies. Whereas I think the EU and Europe has a few different ways they're looking at it, and they have to go through all the process of how they approve and decide. I think politics in Europe, I'm learning a lot about that through all this. At the country level and the commission level and the union, like all of those different places where they have to get alignment, I think makes it a little bit more challenging there. So it's happening in both places. I think Americans also tend to be a little bit more like, let's just go do it. And we'll work on it not being perfect yet as we go. I'm reflecting a little bit, but I guess the good part is now that it is happening in these two major markets. There's a push for, Europe and North America to really come together and figure out how to make sure that when we're trading materials back and forth, that data is consistent. So it's a work in progress.
Well, it will always be a work in progress.
That's right.
There's so much to do that it cannot be perfect, and it's okay. It's like you said, Americans are well known for being more practical, and that's a good thing. It's like you just need to do it. Otherwise, we will still be waiting for perfect measurements on the embodied carbon, that it will never be perfect because you cannot be, exact, 100% exact with this.
As long as we're directionally accurate.
Correct. Well, correct. Yeah.
Like, I think it's,
and we're not speaking about a threshold of like a huge margin of error. Yeah. We're just speaking about, lower margins that
the blue squishy stuff can overlap.
Yeah, the blue squishes. Yeah. I like the name. All right. I don't want to take a lot more of your time, Stacy. I know you're really taking a lot of your time saving the planet. So before we wrap this up, can I ask you a couple of ping pong questions?
Sure.
What do you think is going to be the next big trend in the AC?
Wow. I actually sat on a panel around this with the CEO of COVE tool. I think the use of AI and how we design and construct buildings, and then also in the data side of things. I know it's the buzzword, so it's probably an easy answer. Everyone says it, but we're seeing it in terms of how we actually digitize data and how it's making our work more efficient. I think there is a role for it to increase efficiency. I've seen some cool ChatGPT AI layers where for BEM and for other things, material quantification, all that stuff, people are already playing with that, where it could free us up to do more of that kind of innovative thinking that we do best as humans, and let the AI work with us. So I think, I know it's probably what everyone says right now, but that's my reasoning behind it.
It's a truth. Like, it's coming in, and we still have to implement it in so many different ways. So it is the future. And then, if you can tell a great AC tool nowadays, or AC platform that you consider is amazing.
I mean, I have to say EC3 and Tally, our products are great. But just if I'm thinking about other ones that we use, I appreciate how COVE tool has approached energy modeling. So if you're in the sustainability space and you haven't gone and explored COVE, just in terms of how they're making that side of things easier, I definitely would put a plug in for them. And of course, they're now bringing in the embodied carbon data too, which is great. But yeah, they're good friends. I definitely think they're on the right track when it comes to some of this sustainability data use.
Yeah, I know Patrick and Danielle, and they're doing a great job. Yeah. And if you could collaborate with any person in history, which person would you choose?
Oh, wow. That's a huge question. Anyone in history? I'm thinking for a minute. It depends on what I'm trying to solve for. I think I have a non-direct connection to Bill Gates, and I think his journey of starting on the technology side and then now putting a lot of his calories into solving climate change through breakthrough energy. Maybe this will get me an actual meeting with him, because that would be great. I would love to just sit down with him and compare notes and pick his brain on how we scale this data climate initiative even more broadly. But
interesting, yeah, absolutely. And then, what's your favorite building in the world, and have you ever visited?
That's a great question. It probably won't be like the most intuitive answer that people would expect from me. But I'll go back to my Julia Morgan story. When I was applying to architecture school, my mom agreed to drive me down to Hearst Castle, which is one of the first projects that she designed and then managed. I have a picture of her where she's like at Hearst Castle with her hard hat on, and her drawings, back when that was not a common thing for a female to be doing. And so I got to go to Hearst Castle, and they let me into some of the secret, like non-public places to sketch, so I could include some sketches in my portfolio. And it was kind of magical being there, knowing that, this woman that I'd idolized, I was getting to sketch her project to try to get into architecture school myself. So
cool.
Yeah.
Love the story. And And then before we say goodbye to each other, can you tell everybody where they can know more about building transparency or contact you?
Sure, absolutely. Yep. Just buildingtransparency.org if you're wanting to learn more about our nonprofit and access the tools that we provide for free. And if you follow me, I'm a big LinkedIn poster and promoter. And the best way to get a hold of me actually is just to message me on LinkedIn. And I'll say that out loud. And I love to make connections there and learn more about people. So,
all right. Love what you do, Stacy, and I really appreciate it because it's not only a good thing for our industry, but a great thing for our planet. So I really appreciate what you have shared with us and do expect to know more about the work you're doing in the future.
Appreciate it. Thanks so much.
All right. Have a great day.
You too.
Okay. Bye-bye.
Bye.
Thanks to our listeners. If you like this content, you can find past and upcoming episodes in ascworks.everse.com and at all of our Everse social media. We'd love to hear from you and recommendations for new content, so leave us a DM and we'll make sure to catch it.